Can you open the window, Iad? It's very hot over here.
Cool. Is that fine?
Okay. What were we on? Center of gravity, wasn't it?
Excuse me?
Yeah.
I don't know what is U.
What is U in the formula? Ah, yes. I'll write it here. Who was saying that they used a different letter for U? They used like V.
Yeah, VI. It's VI.
Yeah. Some countries use VI and VF. Did you use this? No. Okay. This is the speed at t equals 0, and then this.
Oh, so it's I. I
Mm,
think so.
A?
It's not.
No. Sorry. What would we call the U? Starting speed. Yeah. Yeah. And the V we call it.
Yeah, I know V.
You know V? The final speed.
Right?
The speed at the end. Starts here with U and then finishes here U meters per second and finishes with V meters per second. Yeah, and then this here is the S, like that.
Oh,
Yeah.
so you're right. You're right.
And yes, we use
Yeah.
MS minus 1 and you
I
use
think-
M slash
yeah.
S. Yeah.
I don't know that.
We said in the first lesson, that was the first thing I said, wasn't it? Yeah. So, what did column use? Did column use this, or did he use slash? Column use slash? Biology teachers. Terrible.
We are proud of our.
Don't listen to them. Yeah, we use minus 1. What does Lorraine use?
But if I use
It's okay, yeah.
We never use anything like.
You haven't used it with
yeah,
Lorraine?
We have used it.
Yes, mass over spectrometry.
Yeah, mass.
That's actually a slash, yeah.
Yeah.
Outrageous. Outrageous. Alright. Now, what did we finish on last time?
The schedule comparing.
Schedule comparing?
No.
The table.
The table we come.
Oh, we made a table, didn't we? Yeah.
I think the topic is completed.
Well, we have to look at some examples.
Oh, there was one question. One example.
Oh no, we didn't do this.
We didn't do anything.
Yeah. So let's just recap some vocabulary. So when we have something that turns, do you remember what this is called?
Turning point.
Yeah, it had many names. So we can call this a turning point, was one name for it.
Yeah.
Another name for it,
Fulcrum.
Fulcrum was another name. And another name for it,
Yeah.
pivot. So this is when we have like this and this and this is turns. So this here is called, and I usually call it a turn-in point, but some places call it a pivot and some places call it a fulcrum, but I like to keep it simple and I'll call it a turning point. Okay, and so what do you think this is called here? This, I call it a turn-in force. Make a turn. But there are other names for it. I wonder if anyone knows other names for turn-in force.
I think it's a moment arm.
Moment. Moment is another one, yeah. And another one from cars.
I saw it. So,
In cars.
In cars
and bikes.
and bikes.
There's a movie.
Excel.
And there's a movie about it, yeah.
Excel.
Oh, no. Begins with a T.
What is it then? You know for sure.
Yeah, what is it?
Torque.
Torque. Very good.
Oh,
Torque.
Or is
It's just another word for turning force. These are all synonyms. They're all the same. So it just depends what area of physics you're in. So when you're talking about cars and bikes and engines, they like to use torque. When you're talking about, you know, more general physics, we like to use moment. And I use turning force because it's just the simplest one. It's clear. It makes it turn. Yeah. So we have turning force and turning point, but you should know the other words for the example. So just make note of those words, please, before we do the definition. Well, if you knew all the words, you don't need to, but did you know all of them?
I know the torque, turning point. No, not turning force moment.
You better write them down. Better write them down. Questions? Yep. So like here with my laptop, this is what's this called? This is turning force, and then here and here turning points, yeah, or pivot or fulcrum, whatever you want to call it. Okay, so that's okay, isn't it? Let's have a look at the definition of turning force. Oh, beautiful, but no. We need to be more precise than that. It does make it turn though, yeah. Okay. So, let's have a look. So the moment, or turning force, is the force times the perpendicular distance from the fulcrum. I'll explain that in a moment. It is basically a turning force. Now there's a lot here, you don't need as much as that. So just before you write that down, let me just explain. So here is your turning point. And then here, whatever it is, I don't know, door or something. And this is a force. And this is a distance. So the turning force equals force multiplied by distance. Okay? So, for example, if this was 10 newtons, and this was 2 meters, then the turning force would be 20, and the unit? Newton meter. Yeah. Now, just please, before we continue, just please note this, just to be clear. If it's at an angle, okay, so like for example, if the force is like this, we have two choices. Our first choice is we can draw a line, like this, and then use this distance, the perpendicular distance, not this distance. Okay? Or if you prefer, your second choice is you can do this. If you want to use this distance, but the force is at an angle, then what you need to do is to resolve it into two parts. This one and this one. And which one do you think you use? The bottom or the top? Bottom, thank you. Yeah, so we call this one fx and this one fy. Now the reason is because if you think about it, if I'm turning the door, the force that goes through the turning point, it doesn't do anything. Like this is going straight to the turning point, it's not doing it. It's actually only the one that goes perpendicular. Good. So it's actually only the one that's perpendicular that you care about. This one here, you don't care.
Yeah.
So you have two choices, and they both give you the same answer. Okay? If you use this force but this distance, you get the same answer as if you use this distance but this force.
Are we always going to be able to choose one of them?
You
Or
should.
sometimes-
You can always choose, but I I find that usually in the exam, it's a little easier to do it this way, because they usually give us this angle. Whereas here is a little bit more difficult because it's more like a maths problem where you have to try and calculate this distance, so then you need to know these angles. It gets a bit messy. But for the exam, it's usually this way. Usually.
So we have
This one will usually be harder.
but not this one. Not
Yeah, because you know, like, if this is theta, then how much is this? If it was 10, it would be 10 cos theta, 10 sin theta, in the example of 10, okay? So anyway, let's have the formal definition. So, this is really what you would need for the exam, the definition. So if you want to write that part down. Yeah? Yes, it's okay? Yeah? Okay. Now you don't have to write the rest down. You can just write some key points if you want. But I just went on to say it is basically the turning force. Like what you were saying, Iyad, how much it can turn. Another word, well, I told you this already, another word is moment, is torque. And as a formula, this is it, force multiplied by distance. I use the letter L for turning force. Sometimes it's a tau, sometimes it's a gamma. Last year, yeah?
So this is force multiplied with distance?
Yeah.
It's like the opposite J.
Yeah, tau is the Greek letter. That's what I used last year, but this year I feel like using L. Different books will use different letters. The reason I'm using L is because that's more common in university physics books, and so I think it makes more sense for you to see it with an L. Okay. Oh, look, I even said it there. Sometimes you use a tau or a gamma. And the units, of course, are Newton meters. I haven't decided which I like, but I think I'll stick with L. But sometimes maybe I'll use this one, because I like this one too, tau. So it measures how much of a turning effect there is. Wait, should that be an E or an A? Turning effect. Is it a noun or a verb though? It's a verb. Yeah, it's A. Right. A big moment means there's a lot of force trying to turn the object. So here's my little picture here. This means there's a big turning force here. Why is it big? Because the distance is big. Yeah. So you don't need to write all of this down. Maybe you just want to write down the formula at least. This, and also that sometimes I use this and this for L, and the units are Newton meters. Yeah, so this is a big turning force. Okay, we continue then? Yeah. So like I said, you don't need to write all of this down, just what you feel like is important. The first sentence is important for the exam. Okay. Right. So let's have a look at the first question. You don't have to write all of this down. What you can do is read it and then draw the picture. You understand? Yeah. So try and draw this picture. A man is trying to free a car trapped in some mud. He uses a 2.2 meter steel pole. He puts the steel pole under the car's wheel and then uses a large brick as a pivot. The brick is 20 centimeters from the car. The man stands, pushes. I think that grammar is broken. The man pushes down hard on the end of the steel beam with a force of 1 kilonewton. What is the moment of this force? Okay, can you try and draw it? Yeah? No good?
Okay, that question what means to free a car trap?
The car is stuck in the mud.
In the sand, yeah?
Yeah, like in the sand. And he's trying to free it.
Oh.
So I just want you to draw.
Only
Draw first.
Okay.
What means free?
The car is stuck.
Yeah.
And he wants to free it. He wants to take it out. Yeah. Hey. Too much English?
What about beautiful? Beautiful.
What's a steel pole?
It's
It's like a long metal stick. Yeah. I don't know. It's not really a steel pole, but kind of like this. This part, except longer. Yeah. Let's draw it. Did anyone? Oh, nice. I'll draw it. You seem a little confused. I'll draw. Yes, looks like it. Look, here's his car. And it's stuck, so he tries to free it. He has a long beam, and then he puts a little brick here. Okay, so in the question, what did I say this distance was?
20 centimeters.
Yeah, roughly 20 centimeters, isn't it? Yeah. Actually, I should say this distance here is 20 centimeters, or 0.2 meters. So how big is this distance?
2 meters.
No, 2.2, so it's 2.2.
Yeah, well, it's 2.2 in total, so yeah, this is 2 meters.
Yeah.
And then he pushes down, although I really wasn't clear in the question, I'm sorry, he doesn't,
An angle of
yeah, he pushes at right angles, I should have said. So he pushes down like this. And that is with a force of 1 kilonewton, 1,000 newtons. Yeah. So, what is this turning force? It's the force multiplied the distance. In this case, it'll be 1,000 multiplied by 2. Yes, because it's only to the turning point. Yeah. So that's 1,000. So that's 2,000 Newton meters. That's okay, isn't it, to get started?
This is a vector quantity.
No, not really. It has a sign. It can be positive or negative, but it's not really a vector actually, because it doesn't. The direction is only one of two possibilities: clockwise or
There
anti-clockwise.
is force in it.
Yeah, I suppose if I was being very technical about it, it's only the magnitude of the force and not the direction. Yeah. Okay. Right, continue. Next example. Okay, so there's only one example left, and then we'll go on to the next lesson. Okay, so again, if you want, you can read it and try to draw it. Or if you can't draw it, you can just write it down. Okay. What's a wrench?
Wrench, the one with.
Oh no, that's a trowel, I think, actually. A wrench is what you use for like
Like to make
yeah,
a
if
hole
you want
in
if
the
you want
ground.
to
Yeah.
open
right.
something like this.
The U-shape key.
Yeah, it has a U shape and you put it
Yeah,
on
yeah.
the bolt
Oh.
and then you
Yeah.
turn it like this.
Monkey spanner.
Very good. Monkey spanner. That's a very American name for it. Yes. Monkey spanner. You're right. Okay. So try and draw this or write it down.
What does the first sentence mean? Back in the
A nut is the thing the wrench goes around. So you use the wrench to
make it back.
make it tight. Yeah.
I will try.
You can try.
You want to multiply by 150?
Yeah.
Hmm?
You are going to multiply by 150.
Mhm.
Is it?
No, 0.2 multiplied by 100
Yeah.
is 20.
So if this.
Correct. Yes. Yeah. Okay. So let me draw it too. Are you writing it down? You don't want to draw it? Did you draw or write? Let me see your picture.
I don't know how to draw.
That's okay. You'll do fine, yeah. Mir? You went for draw?
Yeah.
Let's see.
That's what
You got it right? Yeah,
This
okay.
is the wrench.
Yeah, okay, yeah.
This is the nut and.
Yeah, okay, yeah. Yeah. Alright, I'm going to draw it now. Yep. And so what I was picturing here, you all have that, yeah? Yeah. What I was picturing here, you have your wrench. I'll try and draw it. You know what I mean.
Oh. You call it, you call it
Spanner, maybe?
screwdriver, no.
No, not screwdriver. No.
You call it
I'll just draw it circular.
One.
It's used to, when the tire is punctured.
Yeah, wrench. I can't think of any other name for it.
Yeah.
Anyways, what did I say in the question? It's 20 centimeters long and the force is 100 newtons. Okay, so it's 20 centimeters long and the force when he's turning it is 100 newtons. So then the turning force would be 20,
Multiply with
0.20 multiplied by 100, so 20 Newton meters. Now in the question I said, why is the true value smaller than this? Because this isn't really right. What's wrong with this? It's not really 20. It's less than 20. Why is it less than 20?
Why 20?
Well, 20 is in the question, but I'm saying that the 20 is not really right. What's wrong with the 20? Oh,
Is it
come on.
because of the top of the wrench?
Yeah, go on. What about it?
I can't do it.
Well, look.
It's not like,
No, the distance should be from here to here.
Mm.
So this is actually, it's not really 20, it's more like maybe 19 or 18.
yeah.
Okay? So the question is, why is the true value less than this? Well, it's because we're not considering this distance here. But I mean, this is probably like 1 centimeter, so it's not so important. So the real answer will actually be less than 20. Yeah. Yeah. And when people hold it, they do hold it at
Not at
right
the
angles. Close.
Close.
Yeah. All right, continue. Yeah. Yeah. Okay. So we have some questions. So I think what I'll do is I'll just let you try these for a couple of minutes. They're actually pretty straightforward. And while you try them, I'm going to have a look at the Moodle issue.
Yeah.
Do you want to take a picture on your phone of the questions?
Yes,
Yeah.
please.
So this lesson, we started it last time. So actually question 1, 2 and 3, it was from the last lesson. So maybe you could start with 4. Yeah. Or if you want to use your dictionary, you can use your dictionary for 1, 2, 3. You have a dictionary? Yeah, so maybe you can use that. Alright, do you want to take a picture on your phone then?
Yeah.
Yeah. Yeah.
This is the home.
Whatever you don't finish, yes, finish at home. So I'm letting you work on this for exactly 5 minutes, and then at 12 o'clock we'll start the next lesson. I just want to have a look at Moodle to see if I can easily fix it.
Yeah.
Yeah. So, did you take a picture? Yeah. So I'll close this as well.